In our previous meetings, two previous meetings, we discussed the relationship among variables, different type of variables, like two categorical variables, and we introduced the cross table, and then we talked a little bit about the one categorical and one numerical variable, like the salary distribution of the salary variable among genders, and we discussed how to calculate and find relationship between those kind of variables. But in practice, most of the time, uh, we have to deal with numerical variables. This is the most important kind of relationship in data analytics. So today we are going to discuss this topic, the relationship between two variables, two numerical variables, like uh, relationship between height and weight of people, or for example, the relationship between um, number of years of experience and the amount of salary that an employee receives. So these are two kinds of these are the kinds of variables that we are going to cover today. Okay, so to study um, this kind of relationship, we have to use two measures, two summary measures. Uh, for this relationship, we introduce correlation and covariance, and we use a diagram called a scatter plot. Okay, and these measures can be applied to any type of variable as long as they are numerical. We can apply to any type of numerical variable, and the other point is that we should not apply these measures or these kind of diagrams to dummy variables. Those categorical variables coded numerically. You know that, for example, for gender, we have male and female. We can code them with numerical values like 0 and 1. But those 0 and 1 have no numerical importance or value. So we should never apply these methods like correlation covariance to encoded variables or dummy variables. It is specific to just numerical variables. So what's the scatter plot? Is a scatter of points where each point shows the value of an observation for two selected values. Okay, so it's a graphical method for detecting relationship between numerical variables, and it is also called XY chart. And the purpose of the scatter plot to see if two variables, for example, these points or uh, the coordinates of the values show any pattern, and if that pattern is linear or non-linear, and if this relationship is upward, downward, to define negative and positive correlations. Okay. So this example, now I'm going to show you different measures that we can use to uh, calculate the relationship between these two variables. But before that, have you guys downloaded the StatTools? Did you use the link that I provided to download and install StatTools and other decision tool suite on your machine? I want to make
Yeah,
sure.
I did. I'm
Oh,
not sure if I downloaded the right one, but I'm pretty sure it was the right one. So, but yeah, I did.
yeah, it's a package. Decision tool suite is a package that contains 6 or 7 um, tools, kind of statistic tools. But we need two of them. Just the stat tools for the summary statistic, uh, the tool that we use for the first 3 chapters, and we also need risk for chapter 15 and 16. So the customer service told me that the license is completely free and students are able to use it by the end of the semester. Okay, so if you run into a problem or if you cannot activate it, please contact the customer service and mention my name, our course number, and etc. so they can find out our detail and license number. So I assume that everybody has StatTools installed on their machine, and because it's much easier to work with StatTools than just writing and typing the formulas in Excel. So the scatter plot, for example, for this dataset, called for stat on the PGA, you can download this dataset from chapter 3 module. I uploaded them in chapter 3 data file zip. Okay. Golf stats. You want to see if there is any relationship between numerical variables. Suppose we want to see, I don't know what this dataset is all about, but what we need to know is just to see the numerical variable and see if there is any relationship. Suppose this is earning or salary of a, for example, football or basketball player. We want to see if there is any relationship among all these variables, between these variables and the earning. So we need to first plot it in a scatter plot. One way is to select the columns one by one. Select this column, earning. We want to see the relationship between earning, for example, and number of wins. Control Shift N. Oh, earning. It's not working here. Okay, Control Shift down. And the next one. Oh, these two variables. Control Shift down. Okay, these two variables. The easiest way is to go to highlight these two columns and then go to Insert. I don't know why it's not working. Let's see. Control Shift down. These menus are all inactive. Let me open it once again. And StatTools. Sorry about that. My Excel has problems. Okay. Earning and insert. I don't know why these menus are inactive. Anyway, one way to find the relationship between numerical variables is to select and highlight the entire columns. For example, these two variables, earning and number of wins. Control Shift down, and then go to Insert, and from recommended chart we can select the scatter plot. This is one way, and the other method is to go to StatTools. Okay, and in StatTools first we have to define our data range, the entire data set, and then we need to go to summary graph. From summary graph, from that drop-down list, we select the scatter plot. Suppose we want to see the relationship between earning and number of wins. We assume it as our y and number of win as our x. Okay, and then click OK. Okay, this diagram, scatter plot, shows the relationship between these two variables: wins, number of wins on x, and earning on the y. And then we can fit a kind of trend line. Right click, add trend line. So you see here from this picture that there is a kind of linear relationship between x and y. As x increases, y increases too. So here we can see that there is a kind of relationship between these two variables. Okay, this is one way to find a relationship between these variables, and we can also check other variables. Again, scatter plot. Our y is still earning, and we want to see the effect of other variables like top 10, multiple x's, round, event, age, rank, and player. Non-numeric data. Okay, which one is non-numeric? Okay, rank was non-numeric. So here we can check the relationship between earning and other x's, other variables. In this, in the first one, rank and earning. So we do not have any specific relationship. Again, between player and earning, there is no relationship. For this one, do you guys see any pattern or any trend line that we can fit on this data set? No, there is no relationship in this pattern. And if we can fit a trend line again on this diagram. No, there is no relationship here. Here there may be a kind of relationship between x and y. Select points and then add trend line. Number of rounds and earning are kind of related, but this relationship is not very strong, because when we have a strong relationship, all points or most of those dots or points must be scattered around the trend line. And again, here for this data set, we have we see a kind of not perfect, but relatively good relationship between cuts made and the earning. And also for these variables, top tens, here we can define a good relationship between these values, top 10 and earning. There's a perfect relationship between these two variables. So these two variables are correlated. And for the wins and earning. Okay. That's how we work with Scatterplot. And we can get the numerical report for the correlation and covariance of these variables. We can go to summary statistic and then click correlation. Between earning and other variables. Age, player, and etc. Here is the correlation table for these values for the relationship between earning and other independent variables. There is a strong relationship between earning and wins. This number is 0.7. If it is close to 1 or -1, there is a strong relationship. If it is close to 0, which means there is no relationship. So we have a kind of correlation between earning and top 10 in this value, this variable, and wins, because the correlation value is close to 1. That's how we work with StatTools and Scatterplot to see the relationship. So we can fit the trend line to see the linear relationship between them. So correlation and covariance measure the strength and direction of a linear relationship between two numerical values. The relationship is strong if the points in a scatter plot cluster tightly around some straight line, and if the straight line rises from left to right, relationship is positive, and the measure will be positive numbers. If it falls from left to right, the relationship is going to be negative and measure will be negative numbers. So we can use both covariance and correlation to measure the relationship between two numerical values. Covariance is calculated with this formula, xi minus x bar chart, x bar times y minus y bar divided by n minus 1. But there is one problem with covariance. Covariance is sensitive to the measurement unit. For example, if your earning is based on dollar and you change it to $1,000, you will get the completely different results. So it is covariance is sensitive to the measurement unit. So it's not recommended for large data sets. The more reliable option is called correlation. It is calculated using this formula. Covariance of x and y divided by standard deviation of x and standard deviation of y. And this correlation value is always between -1 and +1. The closer it is to either of these two values, the points in a scatter plot are scattered around the straight line. And 0 means there is no relationship between two variables. So these important points about correlation and covariance. Correlation is a single number summary of the scatter plot. And we have to look for values, those variables whose correlation is close to -1 and a +1. And covariance, as I said, is not very much reliable for the relationship. So we just use correlation as a measure of relationship and a scatter plot as a diagram. Golf set and PGA Tour. Here you see these diagrams. The relationship is perfect between rounds and cuts. We can fit a linear trend on this data. And we can also use pivot table. I'm not going to cover pivot table here in this lecture. Let's work on another example. Okay, let's check your questions. Any questions so far?
I don't really know if it's so much about this, but someone mentioned in chat about a poll for attendance. I haven't done a single one, and it didn't pop up on my phone, so I'm curious about that.
Actually, I have not posted any question on poll everywhere today, but because of the number of students in quarantine, and I have not taken attendance so far, but we have to wait and see what decision will be made, and then we act accordingly.
Okay,
Okay.
because it got talked in chat about the whole thing, and I was like, I haven't touched it since we did the online stuff, so I didn't know if you were taking attendance through that or if you're just
Uh,
seeing.
no, no. So far, no. I have not taken any attendance because, as I said, some of the students must quarantine. They cannot attend the synchronous class. They watch the recording later. So it will be a kind of double standard if I take attendance. It's going to be unfair to them. So up to now, no attendance has been taken, but we have to wait and see what will happen in the future. Okay, where can we find the polls attendance for the attendance? So I already answered. Wait, there are polls for attendance. Yes, but the question hasn't popped up yet. Okay. I have been to all Zoom meetings but haven't completed polls until today. That's okay, but for the next meetings, please make sure to respond to your to those questions on Poll Everywhere. To download DTS Suite, you need Windows and I have a MacBook. Do you have any suggestion on how to get around this? I don't have enough space to set up partition on my hard drive. Actually, I'm not familiar with Mac devices, and I'm not very comfortable with those devices. I think uh, the best people that can give you advice on that would be the customer service in Palisade Corporation. So please contact them to see how you can install on your Mac device. I'm also in the same situation. And there's another option. You can go to our lab, WB216C, and all these software tools are installed on those workstations. But personally, I'm not familiar with Mac and how we can install that. I'm having the same problem with my MacBook. Sorry again. If any of you have a MacBook and has space on your hard drive, you can use Bootcamp to split your drive, okay? My setup wasn't offered in this country or region, so I'm in the same situation. This is bananas. Okay, so regarding the MacBook, please reach out to the Palisade Corporation and talk to their customer service representative to see how you can install and resolve that issue. And if there is any problem, our lab WB216 is always open. You can go ahead and talk to our department secretary, and she will give you access to that room. Is there any other questions regarding this app or DT Suite? DT Suite? Participants. Okay, let's go to oh. So now let's go and work on another example. Let me share my desktop with you. Okay, this is a kind of categorical variable. Step return correlation. These are some stocks like Apple, Cisco, and etc. We want to see if the changes are related. Changes of the values of these variables are related. We can use correlation. Okay. So one way, as I said, is to use these functions like correlation, and then we have to define our data range, for example, between Apple and Cisco. Apple starts with B4 through B100. Let me, and D4 and D100. Let me make sure if I defined, the range correctly. Between D4 and D50 is the last item in the list. D50, D4, and D50. We want to see if there is any relationship between the rise and fall of these stocks in the stock market. These are fictional data for Apple and Cisco stock. Okay, so the correlation is 0.2, which means there is some relationship between them, but it's not too strong. Now we can check it with a scatter plot. First, we need to select this Apple, Control Shift N, and then Cisco, Control Shift N, Control Shift, oh gosh, Control, and then highlight these two tables. We go to Insert, okay, now it is working. From recommended chart, we can select the scatter plot. As you see, we cannot find any upward or downward trend among these scatters, and there is no specific pattern in this data set. So as you see in the correlation, here the value for the correlation is 0.2. And its diagram also shows that there isn't any specific relationship between these two categories. And now we can check this with StatTools. Now we need to select these columns. Let me run StatTools. From StatTools, we first select our data range, okay, and then we go to summary statistic. From that drop-down menu, we select correlation and covariance, and we select all these values to see if there is any relationship between them. And we just need the correlation. This table shows the correlation among all these variables. For example, we want to see the relationship between Cisco and Apple. Okay, Apple and Cisco. Again, the correlation is 0.2. It's not very strong. The strongest correlation that we can find in this data set, for example, between Apple we can find something between Cisco and, for example, IBM. The correlation is 0.4. And now we can plot these numbers in a scatter plot. We can go to summary measure, scatter plot. For example, Cisco and IBM. Trend line. The relationship is linear, but it's not a perfect one. If it was perfect, all these dots would have been around this line. So as this table shows, the correlation between IBM and Cisco is 0.4. It's not a perfect one, but there is some kind of relationship between them. So that's how we work with scatter plot and correlation. We can use either of these two methods. We can visually plot it in a scatter plot to see the relationship, and we can also calculate those measures and then interpret the results. In all of our research projects, we want to find at least in our department, ISOM department. Our work is kind of focused on finding a relationship between two things. For example, in my current research, I want to find relationship between poverty and different economic parameters. So I will have to use Scatterplot and these measures like correlation and report it in my paper. So research in information system is all about the relationship between these variables. We have another measure called regression. The difference between regression and correlation is that correlation just gives you some sense of the relationship between them, but it does not quantify it that. If you want to find the exact numbers and how they are related, how these numbers are related, you have to run a regression analysis. And we can, on this scatter line, we can get that relationship. Control right. See if I can. I'm going to show you the relationship, mathematical relationship between these variables.